Alright, in the previous video we saw a three-step formation of NaCl. Let's see how atoms behave while during these three steps. Alright, how atoms behave while uh, while this ionic bond formation. Alright, and how can we represent this ionic bonding? The answer is simple. We represent this ionic bonding by a dot and cross diagram. What is a dot and cross diagram? Let's see. Now, step 1 and step 2 of this NaCl formation, they take place simultaneously. Alright, sodium atom, it loses one electron. Alright, sodium atom has an electronic configuration of 2 at 1. Sodium atom wants to donate its valence electron. Alright, so this sodium valence electron, it will leave its shell from the sodium atom and it will move towards the chlorine atom. Alright, chlorine has an electronic configuration of 287. Alright, now we're looking at step 1 and step 2 simultaneously, because that is how it actually happens. This sodium atom donates its one electron to this chlorine atom. Chlorine atom has 7 valence electrons. Alright, sodium wants to get rid of its one electron, whereas chlorine wants to add one more valence electron in its valence shell. Alright, so this way both of these atoms will have their octet complete. Alright, so chlorine sodium loses one electron to become 2,8. Alright, from 281 it will become 2,8, and chlorine will accept one more electron to become 288 chloride ion. Okay, so the electrons of these two species are represented by dots and crosses just to differentiate between one another. Now what happens when electron transfer takes place? Alright, this is what happens. Sodium atom now has lost one electron, and this electron is over here with chlorine, alright, with chloride ion. Alright, so sodium ion has an electronic configuration of 2,8 now, and chloride ion now has electronic configuration of 288. These blue were its original electrons, these crosses were its original electrons, and this dot is an electron from sodium. Alright, it is still a dot just to differentiate that this is an electron from the sodium. This is the external electron which is responsible for this negative charge and this positive charge. It was over here, and it had equal number of, when it was with the sodium, the number of protons and electrons were equal, and before this electron came here, number of protons and electrons were equal in chlorine atom as well. Now this electron has moved from here to here, number of protons is now more in sodium atom. Alright, number of electrons in sodium atom has now decreased, and the number of electrons in chlorine atom has now increased than the number of protons. Alright, that is why sodium now has a positive charge, because one electron has left sodium, and this is why chloride now has one negative charge, because there is one more electron added in this chlorine atom. Alright, now these two positive and negative charges, these positive and negative charges are now responsible for the sodium and chlorine atom to remain together. Alright, now these two positive and negative charges will have an attractive force, an electrostatic attraction between them. Alright, an attractive force. And what that force is? That force is the electrostatic force of attraction, that is between the two opposite charges. Alright, now this force keeps this Na and Cl ions together. Alright, this force is what we call the ionic bonding. or electrostatic forces of attraction between sodium ion and chloride ion. These are called ionic bonds because this force is between two different ions. Now, sodium atom is positively charged, chlorine atom is negatively charged, but the compound formed, it is always neutral, alright? All compounds are formed in such a way that they are electrically neutral. They have to be electrically neutral. The number of positive charges equal the number of negative charges. That's it for now. I'll see you in the next video.